Now back to quicksand. Quicksand happens when the pressure pushing soil particles apart is stronger than the forces of adhesion and cohesion that are holding them together. The soil becomes liquefied and it begins to act more like a liquid than a solid. Quicksand is a special case of liquefaction. I'm going to show you how to set up a simple model to demonstrate the forces involved in liquefaction to make sand act more like a liquid than a solid, so you can make your own quicksand. We need 2 soft drink bottles. We need 2 bottle cap connectors, and these are 1/8 inch. So then we need some 1/8 inch flexible hose. We'll need some sort of a filter, like this cheesecloth, to put in to our bottle cap connector to keep the sand from moving into the tube. And we'll need a sharp knife so we can cut one of our bottles. The first step is dangerous because you need to cut this bottle roughly in half so that you have about 12 to 13 centimeters here. You may need to draw a line around the bottle, but on these bottles you can see that there's a line already there. And then you use the sharp knife, the craft knife, and that's where this becomes dangerous. You may need somebody to help you because cutting plastic is not very easy, and it would be easy to cut yourself. And now we need to prepare our bottle cap connectors. They come with a rubber O-ring, which helps them seal against the top of the bottle. You want to remove the O-ring, and then we'll put the cheesecloth or whatever filter material you have, maybe a cotton ball, inside. Then we'll replace the O-ring and attach it to the bottle that you cut, like this. You'll fill the other bottle with water and then put another one of the bottle cap connectors on it, but you don't need to put the filter in it. So we'll just apply that here. And now I'm going to set up my stand. Eventually you'll need some sort of a stand to hold your bottle while you're making your quicksand, but it could just be your assistant's hand. And now we're ready to complete our setup. We're going to attach one end of the 1/8 inch flexible tubing to our cut container. And we're going to put sand in that. We're going to fill it to within about 3 centimeters or so of the top. I'm going to tap it a little bit because this sand is already a little moist, so it's not flattening out very well. There we go. Now then, I'm going to connect the other end of the hose to my water bottle. Now we have our quicksand set up, and what we have to do next is apply pressure. I want you to see the spaces barely that you in between the particles. Soil always has some solids, some liquids, and some spaces, the pores. And those pores can be filled with either air or water. Now, as I squeeze my bottle to add water to put some pressure in, you'll notice that the whole thing is lifting a little bit. Well, part of that is due to the pressure just pushing up, but part of it is that the pores that are filled with air is lighter than water, so some of those pores are lifting the sand with them as it begins to fill. And you can see as it gets darker and darker, and you can see some of those beginning to cave down as those pores fill. Now, I'm going to release the pressure. And when I release the pressure, some of the water that's up here flows back down into the supply bottle. And you can see that some of the pores are opening up again as that happens. Now I'm going to give this a couple of moments to settle. And now we're ready for quicksand. I'm going to put this golf ball here, and you can see that it sits on top of the sand with no problems. Now I'm going to add pressure again. And remember, quicksand happens when the pressure that's pushing the soil particles apart is greater than the tension from adhesion and cohesion that's pulling them together. And as I increase the pressure in there, you see the golf ball begins to settle because the sand starts acting more like a liquid and less like a solid. And if I shake that, agitate it a little bit, the golf ball sinks even faster. This is why if you ever have an experience with quicksand, you need to be still and lay as flat as possible. Because once it's in there, once you're stuck, it's difficult to remove that ball because of the suction that's placed on it as the water moved out in this case. Let's look at another model of liquefaction. In this case, I cut a soft drink bottle roughly in half lengthwise. I've taken my soil and put it in one end of the bottle, and I've got it on a slope. I'm going to add water very slowly this time. The soil is not saturated, but if I add the water slowly, the soil will begin to get wet. And as it wets, there's a couple of things that can happen. First, if I add the water too quickly, I get some runoff. And that might be some of the things that you happen to see if you've been paying attention recently to the forest fires and what's happening. But now you can also see that it's beginning to slump. And if I shake this a little bit, you can see that the soil is flowing because it's acting like a liquid. And so this is what happens in earthquakes. And as soon as something starts moving, it creates its own vibrations in nature. The runoff and the material that you see that accumulated in the bottom, that's common after forest fires because you don't have anything left on the surface to protect it when it rains. So we've seen a lot of that in California after forest fires. It can also happen after grass fires if you have areas with steep slopes. The water hits, runs off, erodes soils with it, and then we had our liquefaction and our soil slumping and moving because it stopped acting like a solid and started acting more like a liquid.